3.5, number 198. So this is the second of the two important problems for derivatives, and that is finding where a curve has a slope with a certain value. As mentioned before. So in this case, the function is x minus 2 cos and we want to know for this particular interval of values, not equal to 0, less than 2 pi. So basically 1 revolution of the unit circle, barring the initial side. And we want to know where the tangent line has a slope of 2, meaning where the curve has a slope of 2. But they phrase it in terms of the tangent line. If they didn't limit the domain values to being between 0 and 2 pi exclusive, then there would be an infinite number of places where this function has a slope of 2 probably. Not necessarily, but probably. So limiting it to this particular interval will simultaneously limit the number of x values where this function has a slope of 2, that is, where its tangent line has a slope of 2. The process of solution is basically the same, except for the end. If this had been widened to any domain value whatsoever, then there'd be a little difference in the end of the problem to make sure we expressed all the solutions in a particular way. But here there should be a finite number of solutions, so we don't have to worry about that in this case. All right, so we need the derivative, right? We're supposed to find where the tangent line has a slope of 2. So tangent line slope, i.e. slope of the curve, is going to be equal to 2. So therefore we need f prime to be equal to 2. F prime is x minus 2 cos x prime. Okay, so using the rules a little more liberally, without showing every little detail as before, the derivative will apply to both of these separately. So x becomes a 1, and this becomes negative 2 negative sign, right? So maybe plus 2 sign, but I'll just write that here very quickly. X there. There's our derivative. Clean up just a little bit. 1 plus 2 sine x. So there's our derivative, and we want this to be equal to 2. So now we're just solving this equation. So that should give us that 2 sine x equals 1, and therefore sine x equals 1/2. Okay, so next we need to figure out where in this interval is sine x equal to 1/2. All right, so for sine x equal to 1/2, it would mean that the reference angle we're talking about would have to be the angle we have memorized that causes sine to become 1/2, which is pi on 6. Okay? So pi on 6, which I memorized from, again, basic trigonometry. The reference angle is pi on 6. Since the result is a positive 1/2, right, we need to know what quadrant we're in. So for sine to produce a positive value, that means we're either in the first or second quadrant. And we're in quadrant 1 or 2. If that's the case, I'm going to draw a picture for this. Should not need to draw a picture, but it may need to refresh your memory about having to deal with these situations. So let's just draw a picture for this one. Okay, so if I've got a reference angle of pi on 6 in the first or second quadrant, it looks something like this. there, and there. So this is a reference angle of pi on 6, and this is a reference angle of pi on 6. Okay. This reference angle here in the first quadrant is the same as the actual angle. So we have that x would be pi on 6 itself. But the pi on 6 reference angle in this quadrant, quadrant 2, right, is not actually the angle pi on 6. It's actually the angle 5 pi on 6, right? From here all the way over to here to the terminal side is really 5 pi on 6. Again, because you're pi on 6 away from pi, right? Moving halfway around the unit circle, you might say, or one revolution, right? Half a revolution is going to be pi units, but you're pi on 6 away from that result. So therefore, you must be at 5 pi on 6. Now, we said our original restricted domain was 0 to 2 pi, so these are the only two values that are occurring in 0 to 2 pi, right? That's one revolution of the unit circle, again, barring the initial side, or barring the positive x-axis. So therefore, as you sweep around from 0 to 2 pi one time, there is only these two solutions, and so therefore that is our answer to this problem. These are the two values where this function x minus 2 cos x will have a slope of 2.